Okay, so I worked this one and it does have a lot of steps. So I'm just going to kind of talk you through the process. They are wanting you to use Excel. And first we need to make sure that we can use a normal distribution. So what you have to do is check for that. So I'm going to scroll back up to the top. So the first thing we want to do, I fill my information out that was given. P is 0.42, the sample is 150, and the population is 400. So let's check to see if we can use the normal distribution. So you're going to do n times p, and it's greater than 5. And I believe it shows you this part, yeah. So you're just checking this, and then you're going to do n times 1 minus p, and that is greater than 5. So we can use the normal distribution. And next we need to check to see if it's finite. And so if this is greater, n divided by n is greater than 5%, which it is, 38%, you're going to use that finite population correction factor. Let me show you what that is. So if n divided by n is more than 5%, it's finite. And so since it's finite, you have this extra part right here that you have to do, n minus n over n minus 1. So we're going to calculate the standard error of our proportion because this is needed so we can get our z-score. So let's do the standard error of the proportion, and it may just be rounding. Sometimes can throw the answer off, so just make sure you round to what they're asking for. The standard error of the proportion. Okay, so this is the part that is tricky to put in, but I'm going to talk you through it. So the square root of, let's look, p times 1 minus p divided by n. So the square root of parenthesis p, okay, which is 0.42, times 1 minus p, 1 minus 0.42. You have to put that in parentheses if you want to do that first before you multiply, divided by n, the sample size, divided by 150. So that's the square root of p times 1 minus p divided by n. Then you have this extra part since it's finite. So it's times the square root of n minus n divided by n minus 1. So if you want it to subtract before you divide, you have to put extra parentheses around n minus n. So 400 minus 150 parentheses divided by 400 minus 1 parentheses, and then you have parentheses on the outside because you're going to take the square root of all of that. Okay, so I can send this to you just so you can look at this formula a little bit closer. So this is the standard error of p, and it's probably going to be the part that is the hardest to put into Excel. Alright, once you get the standard error of the proportion, now we can start calculating our z-scores, and we're looking for 50 and 54 successes. So we'll start with 50, and so the formula is your sample proportion. Let me show you the z-score formula. Is your sample proportion minus your population proportion divided by the standard error of the proportion. So what I did here was first I had to change this into a proportion. So I did 50 divided by 150. 150 is n, okay, and got that. And then over here I did 54 divided by 150. So there's my sample proportions. Now I can get my z-score. So what I did was I actually typed in this value here, 0.3333 minus the population proportion, which is 0.42. Okay, and then divide it by, type in the standard error, 0.0319. Okay, so there's your z-score. For this one, you're going to do the same thing, except you're going to say 0.36 minus C2, which is your population proportion of 0.42, divided by the standard error of the mean, of the proportion. So these are your two values. What's important to note here is make sure you round the standard error of the proportion to 4 decimal places. Make sure that you round the sample proportion to 4 decimal places. Then once you get your z-score, they want you to round your z-score to 2 decimal places. So we found the standard error of the proportion, we calculated the sample proportion, then we calculated the z-score. Now, if we want to find the probability of it being in between 50 and 54, you have to find the probability of each of these and take the larger probability and subtract out the smaller. Now, how did I get these numbers? Well, you're going to do norm.s.dist, and then you're going to type in your z-score, and you want it to be cumulative. So you want to type in true. Same thing here. Negative 1.88, true. And then all I did was take the larger probability and subtract out the smaller. And I got 0.0268, and that is an acceptable answer because the answer tolerance allows for that. I know that was a lot, so let me know if you have any questions about any of those steps.